So today we're going to be learning how to solve equations with square roots. And solving equations with square roots really isn't very different from equations we already know how to solve. Let's take a look at the example of 3x minus 5 equals 43. Okay. Now we know we're trying to isolate x, trying to get x by itself. And so we do that by undoing addition, subtraction first, then multiplication later. And so in this case, the first thing we're going to do is add 5 to both sides. So the 5's cancel out on the left side, and what we're left with is 3x equals 48. We have one more step left. We have to undo the multiplication of 3 and x. And so we divide by 3. We undo multiplication by dividing by 3. So x equals 16. So this is an example of an equation we already know how to do. Let's take a look at one that's almost exactly the same, but with one key difference. In this case, it's going to be 3x squared. 3x squared minus 5 equals 43. Yeah, 3x squared minus 5 equals 43. You might have heard the phrase of SADMET. Okay, in which case we take care of subtraction and addition first, then division multiplication next, and then after that we take care of our exponents. And we're going to be using that today. So we still need to undo that subtraction by adding 5 to both sides. And we're left with 3x squared equals 48. 3x squared equals 48. So we've taken care of the addition and subtraction. We still need to take care of our multiplication and division next. So we'll divide by 3. And what we're left with is x squared equals 16. Okay, x squared equals 16. Remember that x squared is just x times x. So we're trying to figure out what values of x would make this statement true. What times itself equals 16? Well, the way that we undo a squared function is by taking the square root. Okay. Now, we should know this one by now, but in case you don't, here's how you find the square root of something on your calculator. You'll notice the symbol that I drew over both sides. You can find that as well over this x squared button of the calculator. Okay. Now, most calculators have a button that looks like this or something very similar. The way we access that function is by hitting the second. So now you'll see it says second at the bottom of the screen there, and then hitting that button. And now we can just put in 16, close parentheses. All we're left with is 4. Okay, so x equals 4. X equals 4. Now, I mentioned we're looking for numbers that would fulfill this mathematical statement. What times itself equals 16? Well, 4 times 4 equals 16, but so does -4 times -4. That also equals 16. So generally, we write both the positive and the negative 4, but in this class, we'll be focusing on the positive square roots moving forward. Okay, let's take a look at another example. Okay, so another pair of examples where we have 2x plus 1 equals 8. Two-step equation, right? We have to undo that addition, minus 1. And we're left with 2x equals 7. And then we divide by 2. Okay, divide by 2. So what we're left with is x equals 3.5. Okay, 3.5. If we compare that to kind of its matching cousin of 2x squared plus 1 equals 8. Well, here's what we get. We still subtract 1 first. We have 2x equals 7. I'm sorry, 2x squared equals 7. Again, we take care of that multiplication next. We divide by 2. We have x squared equals 3.5. Now, when we take the square root of this, well, when we plug it in, we're going to find that square root again. Square root this time of 3.5. And what you see here is a really, really long decimal that does not repeat. 870828693. It does not repeat. Okay? Does not repeat. And so this is irrational. Instead of writing out this decimal, all you have to do is say x equals the square root of 3.5. Okay? X equals the square root of 3.5. Don't write out this giant long decimal because that's just an approximation. Write out the square root of 3.5.